Hello, this is Tina Lafreniere with Related Faces. In this video, I want to show you how to use Related Faces patented resemblance numbers to help you make important decisions about the unidentified individuals in your photos. Let's look at some of the things that go into resemblance scores, starting with facial mapping. Now, clear photos with relatively large faces generally yield the best results. This photo is pretty typical for the time, and it worked very well. In fact, we were able to run facial recognition on the woman in the photo hanging on the wall in the background, and we actually identified her. Every face that comes into our database is mapped and measured so that we can get the facial recognition on it, and then we store all of that information into our database. This mapped face of Sylvester Stallone does a good job of depicting how a face is mapped and measured. You can see how the face is converted into a bunch of numbers. Because we store the numbers for all of the faces coming into Related Faces, we're able to compare your person to all of the people currently in our database. And if a face is loaded in the future that has a resemblance score of at least 60, we'll add that face to your potential matches too. Now, to come up with the resemblance scores, we start with the raw facial similarity, and then we add or subtract from that score according to any data provided about the two people in the pairing. Here you can see that each user has provided a lot of information for the person in their photo. This, of course, is a best case scenario. When the data is similar, we algorithmically increase the score. But when the data is different, we fractionally decrease the score. The reason we affect the score less when the data is different is that we still want you to see the pairing because it might be a family member or the same person at a different point in their life. So now let's walk through some examples of how data can affect the resemblance score. Since the data you provide can affect that score, it's important that you be accurate as possible with the data. Just to clarify, data is not required for Related Faces to work, but the data can make a difference in the score. In our first example, you can see I provided no information at all about the people in that fake car, so you gotta love that detached fake steering wheel. We're going to pretend this photo is unlabeled. So instead of giving these people names, I gave them each a general descriptor, which is a special feature in Related Faces, and it's to help you label unknown people. You can label people however you like when using a general descriptor, as these labels are private and they're not shared with others. In this case, I called the woman might be a foreman's sister, but I'd never write unknown in the first name blank because then Related Faces would think that her name is unknown, and that wouldn't be good at all. Only names go in name fields. This unknown woman made a very nice pairing seen here, and she paired with my great-grandmother Matilda. And you can see that I have a lot of data provided for Matilda. Since I provided no data for the unlabeled photo, not even a gender or a living status, then our resemblance score really reflects only the likenesses between the faces. And you can see here that they're still very, very similar at 99.88. I encourage you to add any data you have for your unlabeled photos because it can enrich the results. Here, I've added two pieces of data that were basically the easiest to determine. I know this is a female, and I can very easily assume she's deceased because of the photo age, the style of the clothing, and that cheeky fake car. If you look here, you can see that those two bits of data have now increased my resemblance score to 99.89. Now, just to show you how the data you enter can help bring the best candidates to the top and lower the less likely candidates, I've decided to have a little fun with the data. And I've changed my unknown woman's gender to male. Now notice that the conflicting gender data lowered the resemblance score. Plus, a related faces data conflict alert has been triggered. This alert will appear when the data shows the two people in the pairing are unlikely to be the same person based solely on the conflicting data. In this case, one set of data says male, while the other says female. Now, you might think this is a strange example to use, but it's actually a common occurrence between brothers and sisters, especially when they're young enough and they look a lot alike. In this one, Matilda and her brother Arthur, as teenagers, looked very similar, and that is reflected in their resemblance score of a very respectable 89.03. Data differences can also show up when you have siblings that look alike, but there's a large age gap between them. Here are Matilda's sisters, Grace and Lillian. Now, Grace and Lillian are amazingly similar, and you can see that in the resemblance score of 96.14. However, there is a 20-year age gap between them, and this alert is pointing that out. Without the alert, I may have initially confused them as being the same person. Children can also look like their parents. As you see here, this pairing between Grace Foreman and her mother, Minnie, they look a lot alike, and their pairing number is 91.43. And by the way, Minnie, their mom, turned out to be the woman in the picture hanging on the wall next to the piano. And that was a lovely surprise for my family, as no one had recognized who that was. The date alert is also checking to see if a person was alive at the time the photo was taken. So if you see a pairing with this alert, you may want to look closely at them. The data may be trying to tell you something. So now I've filled in data for my previously unknown woman. I've removed her general descriptor and added her full name, birth date, birth and death places. They now match my previously labeled photo of Matilda. And you can see the resemblance score is now 99.96 out of a possible 99.99. What I hope you can see is how important adding data is to proper identification. Even if your person is from an unlabeled photo, you may be able to estimate, say, the photo year and maybe the country. Plus, you should likely be able to assign a sex to that person and maybe even be able to reasonably estimate if the person is living or deceased. Every bit of data helps. Sometimes trying to solve our photo mysteries can be complex. We often have strong genetic traits in our families, and it can be difficult to tell one person from another. As you just saw, children can look a lot like their parents, too. These strong genetics can make it hard to identify people. I inherited many Foreman photos. Most were unlabeled. So I sorted out the photos where I did know who was who. The photos on the left side of the page represent those where I'm 100% sure I know who's who. When you're assessing your own photos, you may find that your group photos are helpful. In my family, these photos are where all the people seem to be identified. I was also able to logic through some of the identities in other photos. Even though my 4 sisters look so similar, their husbands look very different. So this gave me a small number of photos that I could add with the group photos as my identified target people. The photos on the right side of the page represent my many, many unlabeled Foreman photos, which proved very challenging to identify each person. In particular, I want to point out the photo boxed in orange. We were pretty convinced that these are the 3 oldest Foreman daughters, but we didn't know who was who. So I'm going to show you how I was able to figure out the identities by using the resemblance scores. Now, when you have family members who look a lot alike, you'll likely end up with several pages of pairings because we show you the top 40% of candidates from our database. This is a lot more than other platforms, but we did it on purpose. We want to capture pairings with other members of the family or pairings of your person at different times in their lives. These types of pairings don't necessarily produce perfectly high scores, so many platforms don't show them to you. But we understand that less than perfect pairings often hold the keys to solving photo mysteries. To help you focus your search and find what you're looking for, we've created some filters. At the top of the page, you can select the pairings you want to view. I recommend selecting your own photos first, as your own collection is most likely going to be the source of your answers. From these pairings, you'll want to seek out ones made between your unknown person and photos where the people are known. Since I have 4 sisters, I'm trying to determine which is which. I need to find these pairings from all of their profiles. I'll then record the resemblance numbers in a chart. I use charts to compare the resemblance numbers and see what makes sense. I created this one in Excel to make it neat and easy to see, but you can do this on a piece of paper. I find Excel very handy because I can easily add comparisons to my already saved file. And once I identify a person in a photo, then that face is already available in my spreadsheet to become part of my pool of identified people. So let me now show you how I use the resemblance scores to determine which sister is which in the photos with the 3 oldest Foreman sisters. Down the left side, I position the photos where I do know which sister is which. Those are my targets. Each photo with its own row. Next to the face, I noted who's who, Matilda with an M, Louisa with an LO, and so on. Across the top is the unlabeled photo where I gave the girls general descriptors for their related faces profiles. Here, each girl in each photo has their own column, and I labeled them A, B, C. To build your comparison grid, just think back to math class. We're going to put in the cells the resemblance score made between the 2 faces in the pairing. Let's start with the top row, known photo of Matilda. I filled in the score between Matilda and the girl in column A, where the score is 99.77. Matilda and the girl B have a score of 91.18, and the next sister is 84.68. This process is repeated down the grid. In the cells where there's no number, no pairing was made between those 2 faces. Notice that at least one of each identified photos of each sister made pairings at some level with each of the sisters in the unlabeled photos. This just shows how much the sisters look alike. I'm sure many of you have family members that are equally as hard to tell apart. The fact that all 3 of the oldest sisters are in the photo turned out to be a big help. Technically, a person can only be in a photo once. Related faces does not allow people within the same photo to pair with each other. This forces pairings with other photos and minimizes confusion, especially in the cases of twins. I'm also immediately ruling out Grace, as she was born 20 years after Lillian and 16 years after Louisa. Now, I'm simply going to search my results for the pairings made with the highest scores, because our theory says that pairings should point to the correct sister. Please look at the 2 rows for the known photos of Matilda. As you can see from the resemblance numbers, Matilda paired highest with the sister A. The other sisters also paired well with Matilda, but the resemblance numbers indicate the first sister is Matilda. If you look at the rows for Louisa, you'll see that the sister on the right very clearly paired the highest with Louisa. Then if you look at the rows for Lillian, you see similar results for her with the sister in the middle. The resemblance numbers clearly show how much my sisters look alike, and I'm not sure I would have ever figured out who was who without the scores pointing the way. Twins can be quite tricky, especially if they're identical. We've been given permission to share these photos belonging to my friend Denise, who is an identical twin. Our test ended up correctly identifying Denise's sister in every photo. Just look at the scores next to the green arrows. For Denise, we had mixed results. In the top two pairings, Denise paired higher with her sister than she did with herself. But you'll notice she's making a face in the photo, and that was enough to affect the score. In the next set of pairings, where the orange oval is, we correctly identified Denise, but the score is only 0.01 higher than she paired with her sister in those photos. Twins are really tough, but it can be done. We must use our genealogy skills in looking for details, but related faces resemblance numbers are able to help us see those differences. Denise pointed out that her sister has a very slight underbite where she does not. And it's clear that Related Faces was able to discern that difference and correctly identify Denise's sister in every photo. The last thing I want to show you is how resemblance scores can possibly help you identify an unknown person when you think you only have one image of that person. This example is actually the first photo mystery we ever solved with Related Faces when we were still testing the technology. The photo on the far left is a photo my cousin owns. We wondered if it could be a photo of our 2x great-grandparents and their first 3 children. Our 2x great-grandmother died during childbirth, and our great-grandfather, Henry Sr., ended up marrying her sister. The family photo is of Henry's family with Eleanor's sister, Angelina, and 12 of the 13 surviving children from both wives. Of course, when I was loading my photo into Related Faces, I was hoping one of my other unlabeled photos would turn out to be a second photo of her, but that just didn't happen. We had reason to think that this might be a photo of Eleonora. The men in the photo look similar. Look at those mustaches. Our photo and clothing fit the 1870s, which is when our oldest 3 children were born. The birth order and gender of the first 3 children in the photo fit our family. It's a girl, then a boy. So these were good clues, but they couldn't give us the definitive answer we were looking for. But what really helped us to definitively determine this is a photo of Eleanor is the pairing she made with other people in my family. She paired with 3 of Eleanor's children, Anna, Kate, and my great-grandfather, Henry Jr. But the thing that really sealed our belief that this is the only known photo of Eleanora is that she makes pairings with 3 of the daughters of her sister and her husband, her nieces, Ida, Emma, and Laura. As expected, her highest scoring pairings are with her own children. The pairings with her nieces are not high scores, but they make sense to me. Circumstantial evidence can be very powerful when you don't have a second image of a person. You are looking for things that fit and make sense to you, even if the score isn't over 90. This situation is a prime example of why we show you a broad selection of pairings. If I was using a facial recognition, say on my cell phone, I probably would only see the pairing between Eleonora and Anna. I might even have mistaken my photo as being Anna. If you look closely at the bottom 2 pairings, you'll also see that my cousin uploaded this same photo separately. She's the owner of the original, and it was her better quality photo taken directly from the original that made the important pairings with Emma and Laura. Eleonora has made pairings with other faces in our database, but just like with document searches, you have to look at the details and follow logic. These results make sense to me and to my family, and I eliminated the ones that didn't. Our resemblance scores are one of the reasons Related Faces has been named one of the 101 best genealogy websites by Family Tree magazine. And I hope this tutorial has given you what you need to successfully use our resemblance numbers to identify unknown people in your inherited family photos. Remember, they aren't just photos, they're your family history.